called the standard normal distribution. Let's write that down. The standard normal distribution is to extend those regions or percentages of values that fall within a given number of standard deviations from the mean. So if you remember, the normal distribution says that if you have a set of data, so this is the data values, and these data values we put them on a number line. Basically, it says that you find the mean of the data. Let's use a better number. So if you know the mean of the data, we also know that within one standard deviation of the mean, moving one standard deviation to the right, one standard deviation to the left of the mean, you will basically enclose 68% of the data. Now, and the reason is that once we say that it's normally distributed, what that means is that the density function of the data, Alright, I'm not sure what happened, but let's again. So if we have the data set and we have the mean of the data, let me get a pen because we lost them. And so if we move one standard deviation above, one standard deviation below the mean, we're going to find 68% of the data in that range. And the reason this happens is because that data is said to be normally distributed, means that the density function, which is basically the histogram of the data, but the data is continuous, is symmetric around the mean, okay, which means that 50% of the data is above the mean, 50% of the data is below the mean. So the region under the curve right here represents the percentage of values that are a distance from the mean. So right here, this would be 34%. If this value is one standard deviation above the mean, and if we take the mean and we take off one standard deviation, then we have the other 34%. So there's the idea of the density function. Now, what it means to be a standard normal. So standard normal means that you have a data set, let's call it Z, that is normally distributed, the N for normally distributed, with a mean of 0, this is the mean, and a standard deviation of 1. So whenever you have a data set that is normally distributed, the mean is 0 and the standard deviation is 1, we say that that set is standard normal. So right here, let's draw a picture of this. So right here is the set of values. Let's identify that set by the variable Z. The mean of this data is 0. Well, what that means is that 50% of the data is above 0 and 50% of the data is below 0. All right? And this data happens to be normally distributed, which is symmetric around the mean. All right? And the standard deviation is equal 1. Well, what that means is if I move one standard deviation above the mean, right, and one standard deviation below the mean, then right here I'll have 68% of the data, 68% of the data, of the values in that range. Between -1 and 1, I have 68% of the data. Between 0 and 1, I will have 34% of the data. And between -1 and 0, I'm going to have the other 34%, right? And under the whole curve, under the whole thing right here, obviously I am going to have 100% of the data. So you keep in mind that under the curve you have 100% of the values. Now, but the question is then, if we have this standard normal data set And so it means that the mean is 0 and the standard deviation is 1. And we want to know what percent of the data is in this tail right here, corresponding to a z-value, let's say, of negative 1.23. Okay? So let's explain that a little bit better or in more detail. So our question right here is this. So now we have a set that is standard normal. The data is normally distributed with a mean of 0 and a standard deviation of 1. We want to know from the range from negative infinity, let's say to negative 1.23, what percentage of the data falls below that value, negative 1.23. For this, we're going to use tables, but we want to be very clear about the relationship between the area and the value. We always read these tables, in this case, in this book, basically from negative infinity to the value. All right. Obviously, this data, which is what we're trying to look for, this area, is less than 50%. And it is positive because area is always positive. So we want to know again, for a data value equal to negative 1.23, what percentage of data is below it. All right, and we cannot do that with the empirical rule. What we're going to do is we're going to read this value from a table. The table, basically, what the table does is it will have the unit and the tenth of the number right here on the first column, and on the first row it's going to have the hundred of the number, which is, in this case, it's 0.03, and the intersection of those values. Then you're going to have the answer right here. Right, so you get 1.2 and then 3, and right there you find the value that goes right here, which is the area or the percentage of values that are below negative 1.23. Now, so there are two tables. The negative table is when the values are negative. If you keep moving this to the right, and then you want to know actually the percentage of values that are below 1.23, so in that particular case, obviously you have more area. Oh, that's not good. This is up here. Obviously, you're going to have much more area. You're going to have all this area right here, because now you want to know what percentage of the area is below 1.23. That area obviously is more than 50%, and because the data value is positive, you get that value from what is called the positive table. So let's practice this a little bit, because really the rest of this course really depends on being able to read these tables. So let's try to do this video thinking on how to read this table. Let me see one thing. 9 minutes remainder. Okay. Let's do an example. Let's do this example. So this right here is a data set Z. The mean is 0. The standard deviation is 1. This is called a standard normal distribution. To the left of 0, there is a data value 1.23, and we want to know how much area is there, or what percentage of the values are below negative 1.23. So we look at these tables that you will download, which are called the positive table and the negative table. Because that value is negative, we use this table right here. So if you look at this table, we're looking for negative 1.2, which is right here, negative 1.2, 0, 1, 2, and 3. So that's the value right there. That would be 1093. You see, 1093. So that's the area that we're looking for. So this area right here is 1093 or 0.1093. In other words, it's about 11%. So how we read this? So let's write 11%. So 11% of the values of the values are below negative 1.3. For this data set, 11% of the values are below negative 1.3. All right. All right, so that's the answer. Okay, so let's continue. So now what we want is to do more examples of this. So again, we have our data set, which is a standard normal. That means that the mean is 0. That's our data. This is the density function of the data, of how the values are distributed. And they are distributed basically around the mean. Let me get an eraser. All right, and so what we want now is we want to know what percentage of the data is below, let's say a value like 1.23. All right, and then right here would be the area below that value. So again, what is the relationship? The relationship is between a data value right here and the area below that value. So obviously this answer right here is going to be more than 50%, because 50% of the data is already below 0. How we find that value? So in this case we use the positive table. So let's go to the tables and let's look at the positive table. Need to scroll this thing till we find it. All right. Negative table, and then this is the positive table right here. So what we do again, this is where we find the data. This is the data column, and this is the area column. All right. So we go to 1.2, 1.20, 1, 2, 3. That gives me 8907. 1.23, 8907. So that means that this area is 8907, or basically 90% of the data. So the interpretation of this is that 90%, doing the approximation, 90% of the values of this data set are below 1.23. So you see the relation between the data value and the percentage of values below that particular data value. So these tables are always going to give us the area from negative infinity basically all the way to that particular value. So when the values are to the left of 0, we use the negative table. When the values are to the right of 0, we use the positive table. Now, what is very important about this video is to know how to find other areas in which we need to manipulate those tables. So so as an example, let's assume that we want to find this. So let's write it as a probability. So what is the probability that the data value is between 1.2 and 2.25? All right. So in this particular example right here, what we're looking for is what is the probability that our data value is between 1.2 and 2.5. And what do we mean by our data value? Where our data values, our data set is represented by this variable, which happens to be normally distributed, this set of data with a mean of 0 and a standard deviation of 1. Okay, so now if we do this, this is the data set right here. We know that the mean is 0. We know that the density function, the distribution of the set is normal. And we want to know what percentage of values are between 1.2, both to the right of 0, 1.2 and 2.25. All right. Oh God. So that's the region that we are referring to, this region right here. And so obviously that's less than 50%, but how we use the table? So one way of doing that is to go to the positive table and read the area below 2.25. That is all this area, that's too much. The area below, if you go to the table and you read the data value 2.25, then you're going to get all this area. And that's obviously too much. You just want this area right here. But if you go to the data value 1.2 and then read the table, the area section, you get all this area right there. So the answer is going to be subtracting the two areas. Subtracting the area that corresponds to 2.25, because that area is all this region right here, minus the area that corresponds to 1.2. So let's find those values. So we go to the table and the area that corresponds to 0.25 is 2.25, 99.38. You see, that's almost 100% of the data. So that would be 99.48, I think. What is my pen? 99.48 for that one. That is all this area right here, minus the area corresponds to 1.2, and that is 1.2. Is it 1.2? 1.25. The other one is 2.25, so let's rectify that. 2.25. 2.20, 1, 2, 3, 4, 5. 98.78. That's 98.78. So this is wrong. 98.78. 98, almost 99% of the data. At 1.2, at 1.2 we have 88.49. So we have 88.49, and then you take the difference of the two values, and for that I am going to need a calculator. So let's say 98.78 minus 88.45, that gives me 10.33. So that means that 10% of the data is in this region right here. It's about 10% of the data. Right? So let's repeat what we did here. Well, let's do another graph right here. So our job was to find out what percentage of the data for a standard normal data set falls between 1.25 and 2.25. The first thing that we did is we read the table, or the percentage of values that are below 2.25, to get all this data right there, all this data below 2.25, and we get 98.77. We did, that's right, 98.78, which that means basically 99% of the data is below 2.25. But we don't want all that area, we want this area. So what we did is we read the positive table to find out what percentage of the values are below 1.2, and that gave us 88.45, or about 88%, right? And so obviously the area that we're looking for is in the area in between the two, so we subtract the two area values. Just to show you that sometimes we don't get the direct reading from the table, right? So let's do another example. The thing about this video maybe is that you can rewind it. So example, but my program keeps closing. So let's find the percentage of values that are between negative 0.8 and 2.15. All right, So what percentage of values in this data set fall between negative 0.8 and 2.25? So again, our data set, we just everything that we see this variable z, which is really z scores. We know that it's normally distributed. The mean is 0 and the standard deviation is 1. And right here they're really asking us the probability of the percentage of values that fall between negative 0.8 and 2.15. And so just to highlight, we want this area right here. So the question is how we find that area. How much area is in there? Well, we just need to think what the tables do. If we read the table value, the negative table, at negative 0.08, that will give us the percentage of values that are below negative 1.08, which is this data, all right? So it will give us this tail right here. If we read the table at 2.25, but now we read the positive table, so in this case we're going to read two tables, we're going to get the percentage of values that are below 2.25, which is all this area right there, okay? And so in this particular case, we also have to subtract, but we have to read two tables. So what is the area? What is the percentage of values below 2.15? We get that from the positive table. So let's go to the positive table. Is this the positive table? Yes. 2.15. 2.15. Okay. 2.101234. That's 9842. Okay, 9842. All right, and then we want to know what percentage of the values are below negative 0.8. So for that we go to the negative table. So let me go to the negative table, because the negative table gives me those tails using a negative number. If you look at here, this is the negative table, negative 0.8 right here, negative 0.8. That will be about 21% of the data, 2119. 2119. All right, and so this data is the difference of those values, the 9842 minus the 2119 as decimals, and that gives me 9842.9842 minus 0.2119, and that gives me 0.7723. All right. So another example. So in this example, we want to find out the percentage of data, or the probability of finding a value that is greater than, let's say, 2.27. So what are the chances that if we put and these numbers are in a bag and we pull one out, that the number is bigger than 1.7? Or what percentage of values are greater than 1.7? The picture of this is as follows. This is the data set. The data set is normally distributed. The mean is 0 and the standard deviation is 1. 1.27 as a data value is obviously to the right of 0. And we want the area. We want the area, the percentage of values, or the probability that the value is greater than 1.27. So in that particular case, that area is not going to be very big, because we know that 34% of the data is between 0 and 1, and this is 1.27. So that number is going to be less than 16%, maybe 13%, 10%. But how we find that value? This is what we can do. We can use the complement or the symmetry. What do we mean by that? The complement will be as follows. If we read the positive table at 1.7, we don't get the area that we want. We get this area, all right? We get the percentage of values below 1.27 just by reading the positive table. So reading the positive table gives us the wrong area, which is this one, the opposite area. But we know that the area under this curve is 100%. So what is this percentage of values? Is going to be 1 minus the area corresponding to 1.27 in the positive table. In other words, the percentage of values that are below 1.27. If we go to the positive table right here, and we go to 1.27, 1.2, 1.27, 0, 1, 2, 3, 4, 5, 6, 7, 89, 80. We get that this area is 89, 80. All right, so what is this area? That will be 1 minus 0.8980. And that is 1 minus 0.8980 give us 0.102, about 10%. So this is about 10% of the values are in the tail. 0.102, sorry. Now that is, we use the complement. In other words, because we have a way of reading the percentage of values below 1.27, we use that, and then we use the complement, which is this area. They need to add up to 1, so we use that. Another way that you can do this problem is by using the symmetry. And the symmetry will be this. If this area, because this normal distribution is symmetric, then the area below negative 1.27, the percentage of values that are below negative 1.27 gotta be equal as the percentage of values that are above 1.27. These two tails have the same area. So one way of doing this problem right here is to go to the negative table and then read the value of negative 1.27. That area is always positive, and that should give me this number directly instead of using the complement. This is called using the symmetry. And so let me go to the negative table and read the value at negative 1.27 and see if it is 0.102. Negative 1.27. So now we're dealing with the negative table. Oh, this is not a negative table. Negative 1.27, negative 1.20, 1, 2, 3, 4, 5, 6, 7. You see 1020. 1020, that's exactly the same value right here. 1020. All right, so it's the same area. So in that case, what I did is I used the symmetry. Okay, now we're going to do the opposite. If they give us the area, how we find the z-value? All right, so let's do that. Okay, so now what we're going to do is the opposite. So let's answer this question, for example. Again, we have the data set that is normally distributed with the mean 0 and the standard deviation 1. And we ask a question like this: what is P90? Let's see what that means. What is P90? So P90 is the 90th percentile. In other words, this corresponds to a data value. So now this is not the area. So this is a data value, so that 90% of the data is below it. All right, so let's draw a picture right here. So we have, this is our data, and we know that it's normally distributed. The mean is 0, the standard deviation is 1, and now we're looking for a data value. All right, so it has to be to the right of 0, because we want 90% of the data to be below that value. So in this particular case, We know the area, we know the percentage of values, 0.9 below x, and now we need to find x. So we need to find what is the data value so that 90% of the data is below it. So we go to the positive table, but instead of looking for for an area, we are given the area. So let's erase all this that I have here already. So now they're telling us that the area is 90%. So we go to the area section and we get to the closest that we can get to 90%. We have 90.51 right here. 89.97, which one is closer? It seems like this one is closer. We need to get to the closest that we can to 0.9, and we get the values 1.28, 1.28. All right, so the answer is 1.28. In other words, 90% of the data is below 1.28. So 1.28 is the 90th percentile. P90 is equal to 1.28. All right. Let's do another example. We can do the exercises this way also. For example, what is the lowest value? So what is the lowest data value let's say to be in the top 15%. All right, so in this particular case what we're saying is, again, in all these examples we're working with a data set that is normally distributed, with the mean is 0 and the standard deviation is 1. I'm sorry. And then what we know is what is that value set, that value, data value, that is the lowest, so that the area or the percentage of values above it is 15%. All right, so you want to be in the top 50%. What is the lowest that you can get? Well, again, there are two ways of doing this problem, because the thing with the tables is that they give us areas below the value. So we can use the complement. We could say, well, if you are in the top 15%, it means that the percentage of values below you, the percentage of data below you is going to be what? It's going to be 85%. So that means that this is 85%, 0.85. That's the data. So now that's the percentage of values that are below these values that I'm looking for. So I can go to the table, find the closest, in this case the positive table, find the closest that I can get to 0.85 and get the value. So I use like the complement of 15%, which is 85%. I wrote it as a decimal, 0.85, and so then I go to the positive table. Is this the positive table? Yes. I get the closest that I can to 0.85. I think this is the closest. And then I get the z value, which is 1.4, 1.04. Right? So when we talk about a function between two data sets, we have a function between a value and the data and the percentage of data below that value. And so we're using that information right here. The difference is that in this case we want the percentage of data that is below the value, above the value, the percentage of data that is above this unknown value. So what we did is we say, okay, we know if 15% is above the value, 85% is below the value. So we use the 85% as an area to get the data value using the positive table. All right. So to finish this particular video, what we have done is, or what you need to do, is really spend a lot of time making sure that you know how to read these tables, understand what they are for, and understand the relationship between a data value and the area below the data value. Use those tables to find any other range of data and their corresponding percentages. either way, if they give you the area, you need to find the value. If they give you the value, you need to find the area. Okay? I'll send you the next video.